This video is going to describe the sort of the ways and the reasons you might need statistic to be a quality engineer. So if you remember, what we did in class is that we went through a quality plan for an alarm clock, and we decided at what point we should be possibly doing inspections or doing quality checks. And I just sort of want to generalize that to when you've identified a place in the process to do a quality check, the next thing you need to do is to say, well, what exactly are going to be testing? And there's usually three different ways that you can do the kind of inspection, any kind of inspection. One is 100% inspection. So you would obviously check everything, check some aspect associated with everything. And then the other is acceptance sampling, where you will take sort of a sample of things and then either reject or accept a lot or a batch. That's one method of doing it. Another is a control chart, and the control charts are done more within the process, along the process. So it happens in concordance with the process, and you might detect subtle changes in your specifications that you could then react to. So if we look at the first one, we will come up with questions like, well, what would you measure? What kinds of things do you want to measure if you're doing 100% inspection? Will it be things like the weight, some distance, some color specification? What is it you're going to be doing? And then what do you do with defects? So there's not a lot of statistics associated with that if you're inspecting everything. There might be some things about, well, you know, when is it okay and when is it not okay if you're doing a go, no-go, if there's some sort of measurement. So there might be statistics about that. But generally, it's just these things. In acceptance sampling, the questions that come up are what to measure and what do you do with defects, just the same as in 100% inspection. But then you might ask questions about what's the sample size for inspection? Do I destroy the samples or not? Is there operating characteristic curves that you can generate which have to do with acceptance sampling? And what level of risk or the probability of defect are you willing to accept? And then should you have multiple sampling plans? So those might be some of the things that come up with acceptance sampling. And then from that you'll say, well, if these are the questions, what kind of knowledge do I need about statistics to do this? And we're going to cover that in class, looking at acceptance sampling and saying, well, what do I need to know about statistics? And in control charts, there might be some more questions or some different questions. So what to measure, what do you do with defects, what is sample size, how to build the control chart, do I destroy samples, operational characteristic curves, what level of risk, again, multiple sampling, and how do I decide, how do I detect a problem in a control chart? Because it's kind of like a moving process instead of an acceptance sampling where you define a lot. This is more of a moving process. So when do I know there's something wrong in the process that needs to be corrected? So again, what statistics might you need to know in order to do that? And then the last area that you'll need to know statistics associated with quality is that there's some aspects of design of experiments where you need some inferential statistics. These are things like t-tests, ANOVA, and regression. So I would expect that you would really want to know how to do those things also in order to know statistics. So in the next couple days in class, we're going to be exploring what we need to know in statistics, and you yourself will be looking at where you're lacking in statistics and how can we help you to catch up in the area of statistics. All right, see you in class.